Yeah. So very good morning, children. Last session we started the ray optics, so that we discussed only few topics on the ray optics. That is like introduction and few concepts we discussed. So in second session of ray optics, let's quick revise what we done or what we discussed in last class. Okay. In last class we started discussion with the light. Okay, what is light? What are the properties of light? Okay, so these are 5 properties. So the 5 properties how we are discussing in this optic chapter. Okay, then how optics are distinguished into 2 types. So like ray optics and wave optics. Optics divided, as we know. So based upon one condition, that condition I given that. What is that condition? The wavelength of the light is very less than, okay, when you compare to size of the obstacle. Okay, so then we'll see the particle nature of light. That means reflection, diffraction properties of light we will study in ray optics. If that condition, that is what lambda, that is wavelength is very greater, not very less than when you compare to size of the obstacle. Okay, then we will see the wave nature of light, that we will discuss in wave optics chapter. So then after that we started the first property of light, so which is in this chapter ray optics, reflection. So in reflection, what we discussed, what is reflection and what are the important points in the reflection, like angle of incident, angle of reflection, and angle of deviation, and plane of interface or plane of reflection, next glancing angle. These few topics we discussed. In the same way, laws of reflection is very important. Okay, what is the laws of reflection? There is 2 laws. What is the angle of incident always is equals to angle of reflection. Got it? Remember it, this point. And second one is incident ray, normal drawn to the reflecting surface, and reflected ray. Incident ray, normal, reflected ray, all lies in the same medium. Got it? So this is very important for 2 marks point of view. So just go through that. So just already we given the notes, just go through the notes. Just I am quick revising it. So laws of reflection, then we started that object and image. So what is object, what is image, what is virtual object as well as virtual images. So we discussed only 2 about the object only. Just I will quick revise it. What is object? Okay, already we discussed, I am repeating again. So object is nothing but it is a source of light, or it is a point from where the light is diverging from. Got it? So the point from where the light is diverging from or emerging from, that we call as object. I given one example. Okay, so what is that example? If you are standing in front of plane mirror, you are the object, you are the real object, and real object we can capture on the screen. Remember it. So real objects are real, are actual. So real objects are real image we can capture on a screen. Okay, this point remember it. Okay, that is about real object. What is virtual object? So virtual object nothing but it's not real. Okay, so what is the definition I given for real object? So the point from where the light rays are emerging out, or emerging from, or diverging from. Okay, then so virtual now. What is virtual? So it's not real, no? Okay, the point from where the light rays are appear, not actual, appear to diverging from. Appear to diverging from. Right, got it now? So remember the already given the definition also. Just remember that. What is real object? The point from where the light rays are diverging from. Got it? Okay. Next, what is virtual? The point from where the light rays are appear. It's not real. Appear to diverging from. Okay. So that for that I given one example. See how it is, no? Just if you take one light, okay, point source. So light rays are moving in all directions. All directions. If you take one plane mirror. So this is all real object. Really the rays are moving out. okay, moving out or incident on the mirror. Okay, so this is we call a real object. So the image will form some varieties. So okay, I'll give one more example. So this is plane or mirror, or this is plane or mirror. If you take one object at infinite distance, okay, rays are coming from here. So rays are coming from the real object. Okay, so the image will form other side of the mirror. Remember that image. This is image of real object. This is not real image, man. This is virtual, because real, nothing but actual images are real images we can capture. A real object we can capture. Okay, so this is, but how these rays are instant from the source. So that is actual rays. The rays are diverging from the source and instant on the mirror and reflected back and here intersect each other. So if you take one straight line here, so this is object is somewhere it is, and this is what, so for this is what real image, real object, real image, but this is what we call O dash. So why? Because directly object never form the image without mirror. Okay, without mirror. So because of mirror, so the image will form at same side of the object, but in this O dash is called as virtual object. This is what, to form this real image we require this O dash. So this is virtual object for image. Okay, remember it. So we can't see. Otherwise, general example. For example, you are driving the car. Okay, you are driving the car. So you are the object. Assume that your eyes are screen. Assume it. Okay. So you want to see the backside, backside vehicle, but you can't turn your head. No, it's impossible while you are driving. Okay, but it's dangerous also. So you want to observe the vehicle which is coming from you, coming towards you. So which is coming from back. What you will do? You will see the mirror. Okay, you will see the side mirror. Now you see the mirror is the one. You are the observer. Okay. So object is what? Another car. Object is another car. But you are not seeing that car directly. Not seeing. Where you are seeing? You are seeing the car, that is real object, in a mirror. So that car will appear in a mirror. So that means what you will feel, the image, the light rays are coming from the mirror, not from directly from car to your eye. Directly, it's not curves. Okay. So the light rays which is coming from the car, which is your backside, incident on the side mirror and reflected back. So the reflected rays are intersecting on your retina. That is, image will form on your retina. So that is real image. So where is real object? Backside of you. But what you are seeing in mirror? Virtual. Okay, that is not real. That is virtual. So that is, the rays are appears to coming from. Okay, appears to coming from the mirror. So that is what you are seeing in the mirror. That is virtual object. Right? In the same way, while you are seeing your face in a mirror, okay, your face is the object. What you are seeing in the mirror, that is a virtual object. It's not a real. Okay, so that is the difference between real and virtual. So real, in case we will say that actual, the rays are coming out or converges. Remember this point. So we will use the word actually. So the rays where is diverging from or emerging out. Okay. Otherwise, the rays which are converges to. Okay. The point where it converges to. Okay. Actual the word we are using in case of real. The appear to the word we are using in virtual case. Okay. Let's study about last topic, the real object and virtual object. Now coming to the images. So real image. What is real image? What is virtual image? So the definition of object. Okay, given that in case of definition of object, the point from where the light rays are emerging out or actually diverging from. Actual rays are coming from. Okay, so that is we call object. Okay, that is real object. Now, what is the real image? So how the image will form? Because of mirrors. Because of mirrors. So there is one obstacle. So let's see here. This is one mirror. This is one mirror. Okay, one light ray incident on it. Okay, this is a center line, that assume it. One light ray incident like this. So these light rays are coming from the real object, which is at some distance. Okay, this light ray is incident here, and when it incident on the mirror, what happens? It reflected back from reflected back. From here also reflected back. So these reflected rays are intersecting at a point. Real incident rays, real reflected rays. So actually the rays are coming from the real object, and the rays, reflected rays are meeting at a particular point. This is called intersecting point. We indicate it as I. Now the definition of real image. Okay. So it is a point where the rays, reflected rays are actually meets. Okay. The point where the reflected rays actually meets. Okay. This point we call as real image. Real images. Okay. Real object, real image. Already I discussed it. So in case of mirrors, real object, real images both are at same side. Virtual object, virtual image also at same side, but other. Okay, other side. Now this is so real object O, real image I. But where is virtual image? Okay, remember that once again. So what is real image? Okay, so real image. Okay, it's a point where the reflected or refracted, but with this refraction we are using in case of lenses. Okay, but here we are discussing about mirrors, so that's why I am giving the definition based upon mirrors. Okay, the point where the reflected rays are converges to or actually meets. So that point we call as real image, right? So once again I am repeating the definition. Please understand this. Don't by heart. Try to understand. Just I am given the general example. Okay. So what general example I given? So car, while you are driving, so you are observing the car. Okay, got it now. So car is a real object. So what you are seeing in the mirror, that is virtual, everything. So virtual object, where the real image will form? In your retina. Got it? Car is backside, that is real object. Retina, on retina real image is there. That is the incident rays which are coming from the car, incident on the mirror and reflected back, and it meets on retina. So actually the rays are meeting at retina. So that is what real image. Like this. Okay. So where the reflected rays are actually meets that point we call real image. Okay. Now what is virtual? This is real image. Now coming to right here. Virtual image. What is virtual image? Okay, real image I am indicating as I. Virtual image as a I dash. I dash. Same diagram we can take now. Same diagram, because all will present in one diagram only. Real object, real image, virtual object, virtual image. Okay, let's see. So here what happens? Object is here, real object, rays are incident in here. Okay, and so the reflected rays are made set here, that is I. But when you extending of this is virtual now. So which is forming inside the mirror, that is virtual points. Okay, so here what we said before that we called as a O dash. What is O dash here? Virtual object. Real object, virtual object. Okay. Now this point also we can refer as a I dash. How it is? Let's see. To form the image we require object, right? Okay. But object is here, image is here. How the image is forming? Because of mirror. If you without mirror, is the image will form? No, the image will not form without mirror. Okay. So because here we are not considering any observer, object, image. So if you take the object as a mirror, so then image will form. Okay. For this object, okay, this O dash, okay, for this image, this O dash act as a object. Okay. So forget about O. Okay. So this rays will appears to be coming from here. Okay. For this real image, the rays appears to be coming from the mirror. So this is a real image, and how to define this virtual image? Virtual image definition. Okay. So the point where the reflected or refracted rays, okay, appears to meet, not actually meets and not actually intersect, appears to intersect. So these rays are appearing to intersect but not actually intersecting here. That's why I am indicating with the dots. So this O dash and I dash are almost same. Okay, almost, but definition is different with respect to point. When you are considering the object, you have to say it as a virtual object. When you are considering the images, you have to say it as a virtual, okay, image. Okay, same. Definition, small point in the small difference in the definition. While you are considering the object, you have to say it as a the rays which are actually converging or appears to converging. For real case, what you have to say, real object, the rays actually, okay, converging from. Virtual object, so the rays appears to be converging from. Got it? Next. Appears to be diverging from. Okay, appears to be diverging from one point. Okay, that is what a virtual object. In case of image, so real images, the rays where actually converges or meets. Actually appears to be meet, that is virtual. Got it? Okay, that's this is a definition. I'll go with the example. What I said, what example, general example, what we are taking, you are driving the car, you are seeing the one car which is back side of you in a mirror. Okay, now here we need to identify the points. So I'll take the one more example. This is a mirror, here is object, the two rays are incident on the mirror like this. So, okay, so this is a mirror. And here is the observer. Here is the observer. Observer is here. Just like it's a car side mirror. This is a car which is back side of you, and you are there, driver. Okay. So these rays are reflected like this. Okay. Actual rays incident and actual rays reflecting. Okay. So this is what real object. Okay, from where the actual rays are emerging. Okay, are diverging from. Okay. Next, after the reflection, all these rays are meeting on the or falls on the retina. So this is what real image. Real object, real image. Because we can see the rays. Okay, real incidence, real reflection. Okay. So actually emerging from and actually converges. Okay, now coming to virtual points. For this observer, he can't see the object directly, but he will see the image of this object. How it is, no? Just if we extend it along in back direction, these both will meet at this point. So for this, okay, so this is O, okay, and this is what O dash, and also we can take it as a I dash. How it is now? Let's see. When you are considering object, this object real image will form here, virtual image forms here. Got it? For this, for observer, for this image, the real object is here, virtual object is here. Okay, so real, virtual object, real image, virtual image. So this diagram will give the clear information. So this you can compare with any situation of a plane mirror. Just know what I said, car side mirror, otherwise while you are standing in front of your plane mirror in your home, that also you can take the example. Okay, but so when you are taking this point, consider already given the clear notes of this in notes: object, virtual object, real image, virtual images. Okay, so these are some points. Just they may ask for 1 mark. Okay, but you should have idea on this: what is real, what is virtual. So real is always we can touch or we can capture, but virtual we can't. Okay, we'll go to the next topic, and now actual topics will start from here. So only we discussed about reflection. Now about the mirrors we should discuss here. Coming to, so what is mirror? Okay, generally in optics we are studying about the properties of light, study about the light and everything. Reflection, refraction. So okay, for this session we will discuss about reflection. So reflection takes place only in case of reflecting surface, just like mirrors. Okay, how many types of mirrors we can see in general life? So just we will see the plane mirror in our home, plane mirror. So everyone you will see that plane mirror, compulsory it will be there, it should be in house. Okay, plane mirrors. Okay, what is the use of plane mirrors? Just reflecting or seeing ourselves or focusing on points. Sometimes we'll focus sunlight into our dark room by using of our mirrors. Okay, but how that light will be appears in the room? It will be little bit not so much of bright, but it will be okay. Somewhat it is a little bit. But that is by using a plane mirror. Okay, that is done one type of mirror. Next, convex and concave. Okay, there is a types mirror, or we call it as spherical mirrors. We will discuss about spherical mirror. Okay, we are not discussing about the plane mirror, we are discussing about spherical mirror. So spherical mirror means curved shape, curved mirrors. So this curvatures is based upon position of object or position of center of curvature. Again, it is divided into 2 types, convex and concave. How it we distinguish, I will discuss. Remember that spherical mirror. Let us assume one sphere, just like football. Okay, hollow sphere. I am saying that hollow glass sphere. Okay, in this, so this is one sphere, hollow sphere. It's not exactly sphere, just remember that. So this is one hollow sphere, just like football. Okay. So mirror is part of the hollow sphere. Okay. But when you are saying mirror, it should have reflecting surface. Okay. That means in mirrors, one side, okay, one side is reflecting surface, one side is opaque. Opaque is nothing but which doesn't allow the light. Just silver coating. If you take one plain glass, silver coat at one side, what happens? It will act as a reflecting surface. Other side the light will not, even the instant also it will not reflect it back. So because black color. Okay. So another side is reflecting surface. It will reflect the light which is incident on it. Okay, right. So that is mirror. In the same way, spherical mirror is the part of the sphere. Okay, spherical mirror is the part of the sphere. It's a complete one hollow sphere. Hollow sphere. So just you see one hollow sphere. If you cut this hollow sphere, what you will get? You will get one curved shape, right? How this curved shape? Just like a bowl. Just we will see the watch glasses in chemistry lab. You know that. So that type of shape. So this is one sphere. I am cutting the sphere in one part. So just it appears like a one bowl. Okay. This is what curved. Okay. If it is coated one side. So it represents that I am coating. I am giving the one coating which is not allow the light from it. So that is we call opaque. Now it acts as a reflecting surface. It acting as a reflecting surface. And this is what happened. So which not allows the current. So that is this side. Okay, now the shape of the mirror is like this. So this side I am coating with the silver or any other which is not allows the current. Okay, and now it becomes what? Reflecting surface. So this is a one mirror. So when you see this your image, so you can observe that you see the any object, it will you can see the image of the inside the mirror. Okay. Now this compulsory mirror has one reflecting surface, one aperture. Okay. So mirror is a part of the hollow sphere. Okay. Types of the mirror: convex, concave. Convex and concave. So remember that mirror has two surfaces, but one is opaque, one is reflecting surface. Types. Here we are discussing about curved mirrors. Okay, curved mirrors, not plain mirrors. We are discussing about curved mirror. What I said, it's hollow sphere. Okay, so exactly this is the center point of the sphere. Okay, I am taking this part only. I am taking this. So this is our mirror. So I am putting one side like this. Don't consider this one, just for your understanding I am keeping like this. So this is our consideration. This is our mirror. This is our mirror. Okay. Now types of the mirror. First one, concave mirror. Concave mirror or spherical concave mirror. How we can identify that mirror is a concave or convex? Okay, it's depend upon 2 points. Okay, one is position of object, one is center of curvature. Okay, what is center of curvature? Just here, this is a sphere, right? The sphere has one center, right? Okay, this center point I am indicating with C. Okay, center point indicating with the word C. Okay, this center point towards which side? Okay, reflecting surface. I said no. This is what opaque and this side is what? Reflecting surface. So this is what? Reflecting surface. Reflecting surface. See here, if the reflecting surface of the mirror, remember that the reflecting surface of the mirror towards the center of the curvature or center of the mirror. What is center of curvature? This is a curved shape. If you extend that curved point, it will form a sphere. That sphere center point is C. This we call as center of curvature. Okay. Now, if the reflecting surface towards the center of the sphere or center of curvature, that mirror we call as concave mirror. Remember it. What is concave mirror? The reflecting surface is towards the center of the sphere. Toward the center of the sphere. Okay, that mirror we call as concave mirror. Concave mirror. Next, if you take another mirror, okay, second one, convex mirror. Concave mirror example I given here. Okay, so what is the definition? If the reflecting surface towards the center of the sphere, that mirror is called as a concave mirror. Symbolically we can represent like this. If lines are there, this is what opaque and this is what reflecting surface. This is a concave mirror, cave shape. An example for it, in household we will see the spoons, rounded spoons or bowls, rounded bowls. So when you are seeing your image or your face in that bowls, so you can see the inverted image. Okay, it will not be the erected image, it's inverted images. Just so you can try it, so in spoons and everything. So that is, you can take example of concave mirror. Got it? Now, convex mirror. What is convex mirror? See, I am taking one sphere because mirror is nothing but it's a part of this one. It's a part. Now, inside I am coating. I am giving the inside coating. Inside coating. Okay, so that is now outside is reflecting surface, inside objective. In previous case, outside I have given coating, so inside is reflecting surface. Now here where center of curvature is here. Okay, so if you take one object, you can't see. So if you take the one line, if object is here, okay. Now see here the definition. The reflecting surface not towards center of the sphere. The reflecting surface away from the C. Away from the C means away from the center of the sphere. Got it now? Here C will be inside. That is what? Towards the reflecting surface. Here C away from the reflecting surface. So that is the definition. So if you take like this is a representation of this one. Now C is here, reflecting surface outside, inside. Okay, so this is what is the convex mirror refers the mirror which have the reflecting surface away from the center of the sphere. Concave, convex. Okay, in terms of object position, how we can define in terms of object position? Remember that, as we know that curved. So this, let us assume that this is a one sphere, curved mirror. Just like imagine it, this is a one sphere. I am coating outside. I am giving the coating outside. So what happens? Inside is reflecting surface, right? I want to see my face. So which side I am? Reflecting surface. Reflecting surface is what? Concave shape. Okay. If the object towards the concave shape, object is towards the concave shape and it's a reflecting surface. So this mirror we call as concave mirror. Okay. Now here I am giving the coating. This is what reflecting surface. Now if you take the object here, you can see. Okay. So object always towards the reflecting surface now. So this is a reflecting surface. Now object is towards which side? Convex side. So this mirror we call as a convex mirror. Got it? This is one mirror. If the reflecting surface this side, compulsory object should be towards the reflecting surface. So size of the position of the object is which side? Concave side. So this is convex mirror, concave mirror. If you take like this, coating this side and this is a reflecting surface, and I am seeing my image in this mirror. Okay, and this convex side, so object is towards which? Convex side. So this is called convex mirror. Got it? Based upon position of images, okay, we can define. Otherwise, this is a definition. Just remember this, which type of mirror it is, convex or concave. These are types. Okay. Now, so this is simple definitions now. They will not ask, but we should have an idea about on these mirrors, which type of mirror, by symbols. Okay, by symbols. How to remember that in all cases we are representing the mirrors by using of this type of symbols. So these lines represent that coating and this side is reflecting surface. So inside coating, outside is reflecting surface. Okay. Now coming to very important terms. Okay. So very important terms. You should learn it. Okay. Without knowing knowing of idea on these terms, you will not solve or you will not understand any question. So basic points. So if you want to start any derivation, if you want to derive any derivation, you should have an idea of some terms in this chapter. Okay. So for this, I am assuming one sphere. Okay, because we are taking as a mirrors. So for this, okay, C is a point, otherwise I will do one thing. Some important terms in optics. Okay, first term is center of curvature. This indicating with C. First point. What is center of curvature? Okay, I will take one mirror which is convex. Concave mirror. This is one concave mirror now. So coating outside, so the reflecting surface towards concave. What is center of curvature? So this is a curved shape, right? If you extend these ends, it forms one sphere, right? It forms the sphere. So this is curvature and this forms the sphere. The center of the sphere we called as center of curvature. Center of curvature. Remember it. What is center of curvature? The center of the sphere. Okay, or if you extend the curvature of the mirror, so it forms the one sphere. The center of the sphere we call as center of curvature. Center of the sphere, compulsory. For every mirror, curved mirrors, if you extend the edges, it forms the sphere. The center point we call as a center of curvature. Okay. Now, second point. Radius of next. Sorry. Okay. I'll take this. Radius of curvature. Radius of curvature. So radius of curvature we are indicating with capital R. Okay. So what is radius of curvature? Just like what is radius of the sphere? How you measure from center to edge? Now I am saying that here. So radius of curvature is nothing but the distance between center of curvature to the mirror. Center of curvature to mirror. So distance here mirror position. Here center of curvature position. So the distance between mirror to the center of curvature we call as radius of curvature. Got it? This one. Next, third point. Pole are also called vertex. This indicating with P. Pole or vertex. This are also this indicating with P. What is pole or what is vertex? Okay. Okay. So this pole or vertex is nothing but the center or middle point of the mirror. Middle point of the mirror. Just you imagine one bowl, spherical bowl. Exactly the center point. Okay, just imagine this is a one mirror. This is exactly center point. The center point of the mirror we called as pole. Center point or middle point of the mirror we call as a pole or vertex. Got it? Next. Fourth point. Aperture are also called linear aperture. So generally this word we are using or we are seeing in a cameras. Aperture size 0.5 mm aperture size. In microscopes also we will see that aperture size, and some digital cameras they will mention the aperture size, focus point. So this we'll see that. What is mean by that aperture? This aperture is nothing but also called as linear aperture. Linear, that is straight line. Linear aperture or aperture. What is linear aperture? See here, what we are taking here? Mirror, no? This is mirror. Aperture is nothing but the diameter of the mirror. Diameter of the mirror. So what is diameter of the mirror? Let's see here, this is linear distance. Okay, just I want to give them one example. Wait. Just I am taking this bowl now. Actually this is not exactly shape, but I am taking as a reference. Okay. It assumes that I am assuming that this is a concave mirror. Concave inside. Okay, this is reflecting surface. This inside is reflecting surface. Outside is aperture. So this is. So if you form a sphere and exactly at the center, that is called center of curvature. What is aperture? Aperture is nothing but the diameter. This diameter is there, no? This diameter. The diameter of the mirror. So mirror in which shape? Spherical shape. So spherical, nothing but a circular form. We can easily find the diameter. Okay. So that is we can indicating like this. From here to here. This complete the diameter of the mirror we call as a aperture or linear aperture. Aperture or linear aperture. So this term you should remember. Got it? Next fifth point. Okay. Just I will write in new method. First you see that what is center of curvature? The center point of the spherical shape, a spherical mirror. Okay, the center point of the spherical mirror or sphere, that is called center of curvature. What is radius of curvature? The distance between the center to pole or mirror, that is what? Radius of curvature. Next one, what is pole? The center point of the mirror or midpoint of the mirror we call as pole. Next, aperture. What is aperture? Aperture is nothing but the linear diameter of the mirror. Okay. Now fifth point. Fifth one. Principal focus. Principal focus is indicating with capital F. Indicating with capital F. Okay. Let us assume. Okay. C, R, P and aperture is over now. Then I will take it. So this is otherwise before that you will see that axis, principal axis. We will discuss about principal axis. So this is a mirror. The center this is called as pole. If you extend this one, it forms the one sphere. So the center will be here. If you extend this mirror curvature, it forms the sphere. The center point of the sphere is called as the center of curvature, right? What is principal axis? Principal axis is nothing but it is a straight line which is passing from or passing through the both C and P. What is C? It is the principal axis nothing but it is a straight line which is passing through the center of curvature and pole of the mirror. Okay, on both sides. Okay, so this we call principal axis. Principal axis. Remember it? Principal axis nothing but the straight line which is passing through the center of curvature and pole of the mirror on both sides. Okay, that is called principal axis. Next, coming. Principal focus. Principal focus is indicated with capital F. Capital F. Now, so this is a principal axis. I said no. Remember, this line is called as principal axis, which is passing from both C and P. Now, what is principal focus? The principal focus point. Generally, we are using magnifier lenses just to burn the one paper by using of sunlight. Okay, got it. What we are doing in that case? We are taking one paper, we are taking the magnifier lens and focusing of the sunlight on the paper. How we are focusing? Until we will get the small dot, bright dot, we are focusing, right now. So that means what? Object is sun, which is at longer distance, almost infinite distance. So we are focusing that sunlight completely in a small point on the paper. So that means we are focusing, right? So that is point we call principal focus. Or how to define it? Okay, remember that if any light rays which are coming from the infinite distance always parallel to the principal axis. Remember this point is very important. The light rays which are coming from the infinite distance or longer distances always parallel to the principal axis. Always parallel to the principal axis. These lines we call as a paraxial rays. Paraxial rays. So the rays which are coming from the infinite object incident on the mirror and it will reflect and it meets on the principal point or principal axis. So remember that. So it is a focusing point. Okay, it is a focusing point. Okay, well, how to define? When the light rays incident on a mirror parallel to the principal axis. Light rays incident on the mirror parallel to the principal axis and the reflected light focus at a point on a principal axis. The reflected light focus on which part? Which axis? Principal axis. And this point we call as principal focus. Principal focus. Got it now? What is principal focus? The point where the reflected rays which are coming from the Okay, which are the light rays incident from infinite object, or if the light otherwise if the rays are incident on a mirror parallel to the principal axis and the reflected rays are focused at a point on a principal axis. That point we called as principal focus. Principal focus. Next, focal length. It indicating as a small f. Small f. So how we are define this radius of curvature? The distance between the center of curvature to pole as a radius of curvature. Now the distance between the principal focus to pole we call as focal length. Understand? Between P and C, the distance is called radius of curvature, capital R. Between P and capital F, we call as small f. That is principal focus. Okay, focal length. So F, capital F. So what we discussed in terms center of curvature, radius of curvature, and pole, aperture, and principal axis, focal length, and focus point. So already I given the note, just revise it. So in next class we will go through the sign conversions, how to measure the distance of object and images, and one relation, the relation between capital R and capital R and small f. Focal length and radius of curvature, what is the relation between that? And it's a very important derivation, so compulsory. So we'll discuss in next class. If you have any doubts, we'll give the time to between 2 to 4. Just you can raise a question. Okay. So thank you very much.